housekeeping announcements before we begin. As I've stated earlier, at this time, if you could please add your name and affiliation to the screen for yourself. The way you do that is to hover over your image. 3 dots will appear. And from there, if you move down to rename, you can then add whatever text you'd like above your image. So again, please add your name and affiliation. If you have any problems, please use the chat feature and we will assist you. If any of you will be using slides as presenters, please use the screen share function on Zoom to do so. And after each agenda item, there'll be time for questions. We ask that you please use the Q&A feature in Zoom to submit your questions. It looks like we have participants still joining, so perhaps we'll give it 1 or 2 minutes more before we start the event. All right, good morning. I'm just going to repeat some housekeeping items here before we begin the actual event. Please, those of you who have just joined and haven't already done so, please add your name and affiliation. You will do so by hovering over your image, finding the 3 dots, clicking on those 3 dots, and then going down to rename. And from there, you can type in any information that you'd like. During today's event, if you have any problems, please use the chat feature, and we, as the staff at the Institute, will assist you. For those of you that will be making presentations, please use the Zoom screen share feature to do so. After each agenda item, there'll be time for questions. Please use the Q&A feature on Zoom to submit those questions. So welcome to the Simons Institute's Quantum Industry Day 2021. My name is William Humnicki. I'm the Director of Operations and Planning here. I would like you to please note that during the event today, I will be timekeeper. So when there's 5 minutes remaining in each segment, I will be speaking up to notify you that that is the case. And again, at the end of each segment, I will notify that time's up. It'll be up to our scientific leadership to decide if they want to extend at that point. And please note that this event is being recorded. So I'd now like to turn over the event to Shafi Goldwasser, the director of the Simons Institute, and Umesh Vazirani, Research Director for Quantum Computing at the Simons Institute. Please, Shafi.
Hi, everyone, and good morning. At least in California, it's good morning. So I'd like to welcome you to the Quantum Industry Day, which is the first of its kind. We have industry days every year, but this year we have a special day, which is just dedicated to quantum computing. So I'm the director. I've been a director for the last coming on 4 years. I wanted to share a little bit of information with you about the Institute for those of you who are new to our Institute. And then I will pass to Umesh Vazirani, who's our research director for quantum computing, and he'll tell you all about this particular day and about quantum computing at the Simons Institute. So I'm going to share my slides now. I hope I have a few slides, and I'd like to show them to you. Here they go. Can you see them? I hope you can. All right. So the Simons Institute was founded about almost 10 years ago. So it's going to be a 10-year anniversary this summer. And it was due to a very generous grant from the Simons Foundation. And the mission is very explicitly dedicated from the beginning to explore computation, the nature of computation and the limits of computation, and expand the foundation of computing, the mathematics behind computation through collaborative research programs. And when we say foundations of computing, we really don't just mean in some abstract sense, but as it touches many other fields, not only mathematics, but natural and social sciences, which is very relevant today to physics, biology, economics. We have programs that touch with engineering and technology directly, a lot of activity as in the foundations of cryptography, security, privacy, and a lot of activity in machine learning and data science in the last few years. We are the only research institute in the world that's dedicated to the mathematical foundation of computing. So there are research institutes dedicated to mathematics, the MSRI up the hill, for example, in physics. But really, if you look at the angle of computation and the mathematics computation, we are very unique this way. And part of the reason that I think that Jim Simons believed, and we believe that this is very important to do this research with this particular focus, is that there's been a huge impact of basic ideas, theoretical ideas in computer science in the world around us. You know, whether it's electronic commerce or cloud computing or search or cryptocurrencies these days or quantum computing. It really is very easy to trace the idea to some basic theoretical question that was studied and an idea that was invented and made its way to practice. We are a collaborative research center, which means that the way we operate is through convening researchers together. We have several structures for convening. One of them, which is sort of the pillar, is the semester-long research programs, of which we have 2 each semester, so 4 a year. And the participants are leaders from around the world, rising stars and senior people. And usually we have a boot camp and then 3 workshops, which are dedicated to specific topics. We have weekly seminar series, reading groups, you know, graduate courses, distinguished lectures, and so forth. And Umesh will tell you what we're doing with respect to quantum, what we've done in the past as well. We have summer clusters. So these are shorter programs, bring less people together to study more focused topics. And then our new vehicles, research pods, where we have something that's beyond the summer, beyond the semester, lasts for 2-3 years, maybe more. And it's a group of senior researchers and postdocs or junior researchers containing sustained research in an area. And every once in a while, it's punctuated by research programs and clusters where we bring more people in. And one of these research pods, again, is going to be dedicated to quantum, and we have it right now, and Umesh will speak about that. I just want to say that it's a pity that you can't come and visit us in Simons, because we have, or that we've decided at least that it will be the best mechanism today to do this online. We have a fabulous space on campus at Berkeley, which is a beautiful campus as is, and I believe that our building is one of the most beautiful ones, with a lot of common spaces for interaction, whiteboards, and various kind of convening spaces. So we hope that in the future we'll see more of you in person. Just to finish what we're doing more generally this semester, we have 2 programs going on, and we have many, many postdocs. So I just have a few more slides to punctuate sort of what we're doing this semester. So first of all, we have an expanded postdoctoral program. I know that a lot of our industry affiliates and partners are interested in sort of the younger generation coming through the pipeline. So we will really have a very large cohort of postdocs, about 54 of them. Some of them are associated with a particular research program, about 8 per program. But we have also postdoctoral researchers that are associated directly with the quantum pod. We have also a machine learning pod, and there are postdoctoral researchers associated with them. And then more general Simons Berkeley postdoctoral researchers who are mentored by faculty members in Berkeley. And altogether, it's going to be about 54 postdocs in the next, over this year and next year. And some of them are associated with NSF funding, from DARPA funding, with industrial partnerships, and Simons Foundation itself. The programs, often the people who come to the programs, sometimes we name them as fellows, named in association with our industrial sponsors. And here are some associations with the industrial sponsors and the postdocs who are named fellows. And finally, we have two programs this semester. One of them is the computational complexity of statistical inference. The organizers are, as you see, are from around the world, some from MIT, from UT Austin, from elsewhere around the globe, Stanford, and from Berkeley, Yale. And we've already had the boot camp. We've had a fascinating workshop a week ago, and there are two more to come. And here the whole issue is now, with the emergence of statistics as a major vehicle for discovery, can we start talking about the complexity of samples in the same way that computer science has been known to study time and space complexity. Another program is geometrical methods in optimization and sampling, which is highly related actually with the first program I mentioned. Again, we have leaders from around the world, including Berkeley. Again, we've had the boot camp, and we are going to have 3 more workshops coming up. And now I want to turn over the baton to the really man of the hour, which is Umesh Vazirani, and he's the research director for quantum computing, and he'll tell you, the rest of the story. So Umesh, do you want me to switch the slides?
No, yeah. Let me share my slides.
You're going to share your own. Okay, so I will get out of sharing mode. If I manage to do so, let's see. So I think I stopped sharing.
Okay, great. Yeah, thanks a lot, Shafi, and yeah, welcome everybody to this event. As you know, we are at a pretty unique point in history. It's a really exciting time in quantum computing right now, and we, in a sense, our field suffers from an embarrassment of riches, both in terms of the exciting questions, the techniques, the energy, as well as all kinds of resources. So at Berkeley too, we have our share of these riches, and so we have these 2 new major institutes. There's the NSF Challenge Institute for Quantum Computing, CIQC, and the DOE Quantum Systems Accelerator, QSA. And actually, they have together funded, in conjunction with some funding from the Simons Institute, Simons Foundation, for this research pod in quantum computing at the Simons Institute. Now, this brings together actually all these centers and the research pod bring together people from various areas: physics, computer science, experiment theory, etc. And so today we'll have short presentations from each of these, but also we have these 2 fabulous panels. So what we're hoping to do through this event, to understand where we stand in quantum computing today, what are the challenges ahead, and also there's a lot going on in both academia and industry and federal labs, and how do we create a forum where we bring everybody together to understand both what the challenges are and how we can help each other in this process. Okay, so let me just say a little bit about, Shafi already referred to this, that at the Simons Institute we have these semester-long programs. So we had such a one on quantum computing in 2014, and then also last spring, we had a quantum computing program that was co-located with a program on lattices, algorithms, complexity, cryptography, which, as you can imagine, was very closely tied. There were deep connections with the quantum computing program, and so this co-location was extremely useful in terms of developing research questions and directions. And so, in a sense, what this research pod in quantum computing does it takes this co-location idea to, sort of to the limit, in the sense that what this does is it creates a group of postdocs and senior visitors who are here, continuously for over the next several years, and they will get to, of course, talk to each other and and work on exciting questions and talk to the campus community, but also they get to interact with the visitors at the programs, which include as we saw, lattice cryptography or machine learning, algorithms, complexity theory. And so it's really quite a remarkable, environment. So in terms of, so we have, we have a large number of really great postdocs who work on various aspects of quantum computing, from algorithms to complexity theory, crypto, senior visitors who visit the Simons Institute for a semester or a year at a time. We've had a colloquium that we've been running since the spring. Which was designed to deal with this issue that at this point there's just various areas are moving so quickly forward, and it's so hard to separate out what's important and what's not, and to understand the field, and where even experts are having trouble keeping up with things even slightly outside of their narrow sub-area. And so this colloquium was designed to sort of make some of these ideas more transparent and bring them to people. And to do this, we also added tutorials, but more importantly, panel discussions at the end of these colloquia. And these have been incredibly successful, in the sense that they bring a lot of people together, create a sense of community, and also get people up to date in what's going on. This summer, we actually decided that it was enough with virtual presence, and we organized a summer cluster in quantum computing, and it was I think it was really nice for all the participants to be together and working in person and talking to each other and brainstorming. Let me just very quickly, because I'm really nearly at the end of my time, let me just give you a sense of the sorts of research themes that happen here. So, well, a lot of the research happens at the boundaries. So, for example, there's complexity theory and quantum computing, quantum supremacy. So how do you know that you actually achieved quantum advantage? So there's ongoing and recent work, on how do you know that random circuit sampling, which was the Google experiment, can we sharpen the complexity theoretic evidence that really does solve a problem that's not classically solvable? Or there's more recent work on whether the output of the random circuit sampling experiment is certifiably random. There's also a bit of a revolution underway at this intersection between cryptography and quantum computing. Through the ideas about what else can you do in terms of certified randomness, in a scalable way through cryptographic techniques, but also, how you can make sure that all the cryptography that's been built up over the years, which parts of it remain secure under quantum attack when you have post-quantum cryptography. There's a lot of work on simulation and quantum many-body systems, both in terms of structural properties and the performance of this, algorithm, RRG, rigorous renormalization group. And then there's work on quantum benchmarking, how you can use random circuit sampling to actually do benchmarking of the noise in near-term computers in some somewhat provable ways. Okay, so I'm going to stop here because I think we are out of time, and we should really be moving on to the panel, which is, I think, something that all of us are looking forward to. So, okay, so let me stop there and